All right, we should be good.
All right. Good morning, good afternoon, good evening, everyone. Uh, Welcome to our webinar on developing multiple path root cause analysis, brought to you by the AESQ Problem Solving SMIG. I'm Marnie Ham, and I'm co-presenting with Peter Papadopoulos and Adam Rogers. As you can see, we're from GE Aerospace, Pratt & Whitney, and Honeywell, so a variety of companies. This is our agenda. I'm going to walk us through the introduction and then leave it to Adam and Peter to take over the presentation, and I'll wrap up. So for everyone's knowledge, if this is your first AESQ webinar, this is being recorded today, and in a couple days, it'll be available on the AESQ events page as a past event for viewing at any time by anyone. If you have any questions, please enter them into the chat. We will, at the end, go through what's in the chat window and answer questions. Please remain on mute so that the background noise is eliminated or reduced. Thank you. So the problem-solving methods subject matter expert group, or SMIG, subject matter interest group, are the authors of RM 13003, and we provide that reference manual to help support the implementation of AS 13100 in different methods of problem solving. So all of this also supports AS 9100. So a little bit about us. This group has a mission to develop knowledge and understandings for all of the AESQ supply base on how to apply and use standardized problem methods so that we can mitigate reoccurring problems and achieve the goal of zero defects. Our subject matter expert group, or interest group, sorry, has the goal of increasing communication across the supply base, increasing knowledge of how to solve problems, big and small, using the various methods we present in the RM. We work on keeping the RM current as either issues arise or suggestions come in. And then we want to get buy-in across the supply chain. So we do a lot of work on the reference manual. We provide feedback to AS 13100 on areas of problem solving. We provide webinars and training like this. And then we also have a community of practice, and you'll see that in a moment. This is our team. So we meet weekly. The subject matter interest groups, as you can see, a variety of people from around the world from various companies. We are here as experts to help address problems and issues around problem solving. And later in the webinar, slide 25, you'll see our schedule of events for the year. So our gold book, the RM 13000, you can see on the right here. We also have on the website supplementing templates for how to do 8D in formats like Word, PowerPoint, Excel. We provide those things, we update those. We also have a LinkedIn community of practice. So that is shown, that link is at the bottom, or sorry, the information is at the bottom. You can also just go into LinkedIn and search RM 13000 and you will find us, we will pop up. So we try to provide support there as well as post information. All right, I'll pass
Thank
it
you,
off to
Marnie.
Adam.
Yeah, thank you, Marnie. So again, welcome everyone to this presentation. If you attended our previous webinar on practicing the 5 whys for 8D that we did last September, this information will build on what was presented in that webinar. So we're excited to present some of the same case studies with a more in-depth approach, aligning with multiple path root cause analysis, as well as some fault tree information. So when we're performing root cause analysis and identifying a single chain of events does not always provide the complete answer. For why the event occurred, we may need to look at alternate paths, contributing factors, and so on. So many times we must explore multiple paths of cause to the event. And in this training, we'll not only review the 5Y analysis, but also look at that, how it applies in a multi-path scenario, and also explore the use of fault tree analysis. We'll look at logic gates as well as examples of how you can apply this. So it should be noted that cause chains don't always have one path, right? We initially talked about the 5Y technique. It was developed as part of the Toyota production system. And the original statement about 5Y came to be was that by repeating 5Y 5 times, the nature of the problem as well as its solution becomes clear. And obviously, this is very well documented and works very well. But there are times when you may have 5Y in multiple paths, and it's we're going to see how that chains that we develop using the 5Y process may branch out and lead to multiple causes. And that's what we're going to explore through today. All right, to Peter for the next couple of slides.
Yeah, I actually had it on mute, but hello everybody and welcome again today. So the fault, actually, I don't know if you guys are willing to do this or not, but raise your hand in the reactions if you've thumbs up or do whatever you want. Have you seen a fault tree before? Just to kind of gauge, people's awareness of fault trees. If you see a send a reaction button, a little smiley face, yeah, put a raise hand, a thumbs up. I see 1, 2, 3. Hey, some people come from the bottom of the screen. All right, awesome. Another one up there. Quite a few people. That's good. Awesome. It's a great tool. I highly recommend it. The good thing is a fault tree is a top-down approach. Actually, typically, awesome. I like the thumbs. There you go, Patsy. Appreciate that. But the fault tree is a top-down approach. If I have a problem, and I look at the analysis, it's a general conclusion, right? That attempts to determine the specific causes as you go down. As a matter of fact, typically when we see a 5Y, it's in like a format of a fault tree, except it's a straight down path. And as we know, not every fault has a straight down path. Actually, in a later example, you'll see that there could be a circular path. Instances where that happens, but it's unintended instances where that can happen. But the fault tree does contain logic and gates and or gates. That's the big difference, right? So when we look down a fault tree, like from a 5Y, it's like this caused this to cause this to cause this. So that's the or, but we only consider one or. The and, when we talk about it, has multiple things to it. So when you're drawing a fault tree, you will see that half-shapen moon and the words and. That means for that failure to occur, or that cause of the failure, or a failure within a failure as you're going down that tree, they both have to occur. So that's a half circle at the top. If you have an or, any one of these failures occurs, then the final, failure mode or the final result happens, then it's an or a kind of a pointy emblem with lines at the bottom. And again, the lines at the bottom are the different things that must occur in our fault tree. I think the easiest way to do it is if you can flip slides, is to show you an example. For example, it's a very common well, I think understanding to have fire. What 3 things, and there's a hint there, 3 things that you need to have or create a fire? You know what? Use the chat window. Put your answers. What 3 things? Name one of the 3 things. Name all 3 things. Use the chat window. What are the things that we need to create fire? Ignition. Yes, Alina, if I'm saying it right. Ignition is 1. Fuel, says Patsy. Yay. And oxygen. Fuel, heat, and oxygen. Heat or ignition, I would take that. Oxygen. You guys are 100% correct. And if you ever study this or read the physics behind it, you cannot have a fire without all three. Having oxygen in the air, having fuel around, that's not enough. I'm currently in the lovely country of Greece, and there are everywhere signs right now because there is a heat wave going on. It says, beware of fires, because the number one problem at this time is you have oxygen in the air, you have very, 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 very dry trees and leaves and pine needles that are on the ground. They're not going to catch fire by themselves. It's the ignition source. And exactly as in the example, got to be wary of people throwing cigarettes and hitting the ground and hitting that fuel and having the oxygen in the air, right? A spark of any sort, right? Not putting out your flames in a campground, right? So all of these sources can create, larger and larger fires that exist, but you cannot have a fire without all three. And so typically we talk about the ors, or the 5 whys are the sequentially what happened. This is an and. I can't have it happen unless all three things happen. Great example, but probably not enough to really give you guys, to work with. So we're going to give you some more examples. How about your computer? If you sat down on your computer today, right, and said, oh boy, my computer doesn't work. Well, there is multiple ors. You can say, well, my CD-ROM or my CD-ROM crashed and I can't use that. That's an or. And by the way, I have 2 CD-ROMs. So that's an and. For me not to be able to work on my computer and I need to use the CD-ROM, one or the other has to break. But for me not to be able to use it, both of them have to break. Okay, that's the and feature, right? So think about that when you're dealing with root cause and corrective action. The root cause, is it an and? Or the hard drive could have crashed, or the CPU doesn't work, or the keyboard doesn't work, and that's why I'm saying it's broken, or the monitor doesn't work, and I just don't know that it's already on, right? So these are all ways that someone can come to work tomorrow and say, oh, my computer doesn't work, right? And we have to realize sometimes it's an and. Well, if I have redundant systems, both systems have to fail, right? And that's, by the way, if you ever study probability and failure analysis, right? When you have an and, the probability of it failing is the probability of both failing, right? So in redundant systems, if I have, for example, a 1% chance that my CD-ROM failed and a 1% chance that my CD-ROM drive E failed, same maker, same failure rates, my overall calculated rate of redundancy really is a 0.1% chance, a 1% chance of 1% chance, or 0.01%, I think. Yeah, 0.01% chance of it failing, right? So that's an and, that's a redundant system. And by the way, a lot of times we have to consider that this had to happen and that had to happen. Reviewing an escape recently, right? We had it went through manufacturing. It had the escape or the issue with it, right? And you can say, and the check fixture didn't catch it. So for it to make it past the next phase or the next process step, both had to be an and. So in our analysis of the probability of this happening again, we analyzed both things happening, right? For our FMEA, for example. All right. Now, overall, if I wanted to look to see what my probability of reliability in the system, which is probability of failure is 1 minus reliability, you really multiply all of those ors together and do 1 minus that of the probability of it working, right? And so if you look on that chart up in the corner, so this is kind of a CQE type exam question, when I'm analyzing a fault tree, and again, fault trees are very common in reliability analysis and a great tool when talking about root cause, that we multiply, the two together to get the one and then all of the ors at the probability of it working together are multiplied, and then 1 minus that is the probability of failure. So in this case, if you look at all those different probabilities of the monitor failing, the keyboard failing, the CPU failing, the hard drive failing, You do 1 minus each one of those plus the calculated and 1 minus the multiplication of all those together. That's what's up in the FTA example, the fault tree analysis probability of failure example. All right. So think about it. You can apply it to the previous example of what's the probability of having a fire. It would be the probability of each one of those things happening, right? The probability of having fuel, the probability of having oxygen, the probability of having an ignition source. All right. Again, any questions, post them in the chat. We'll get to them at the end. Next slide.
All right. So we'll talk a little bit about Bob today. So you'll see him in several examples. He has a lot of trouble getting to work. So, all right, this is our single leg cause chain. We're going to start this off as kind of a review of where we did our 5Y analysis before. So Bob did not arrive at work on time. That's our event. That's what happened. And we're trying to figure out why that happened. So we're going to ask why. Why did Bob arrive late for work? Well, we found that Bob's car wouldn't start. So he begins to investigate and understand why the car wouldn't start. Well, the car battery was dead. So we ask, well, why was the car battery dead? We do some more investigation and come to find out the car dome light was on all night. And so he wants to know why the car dome light was on all night. And he found out that his children had played in his car the night before and left the door open. And this caused the dome light to be on and drain his battery so that his car wouldn't start. And that's a very linear and straightforward analysis. It's good. It arrives to a root cause that we can address. But what if there are other causes, other legs in this chain? So let's look at what that might look like. So we start with our same event. Bob didn't arrive at work on time. And it may look similar as we start to build it out, where his car wouldn't start. And we still ask ourselves, well, why wouldn't the car start? Well, because the car battery was dead. We've established that. But what if we added or, as Peter was just talking about? So what other types of causes might we consider as to why the battery was dead? You can put some examples, some ideas in the chat window if you'd like. We can see what other thoughts there may be out there as to why Bob's car wouldn't start. Why was his battery dead? Any thoughts? Any things we could look at might be contributing to this? Okay, we've got an old or damaged battery. No gas. That's a good one. Yeah. Old battery. Headlights left on. Alternator not charging. Too cold. Excellent, excellent. Lots of good feedback there. So we're going to consider a few. I don't think we have room for all of those. Faulty alarm, draining power, key fob battery. Wow, lots of things we could consider. So let's just look at a few of these. So you guys have great answers for those. And we're going to consider a few of these. Obviously, you've come up with more than what we have. But our first on the left there with the car dome light was left on. So that was we had before, but we also introduced the possibility of a corroded battery terminals. I saw that mentioned in the chat. The failing charging system, potentially some issue with the charging system not providing a full charge to the battery, and maybe an aged battery. Again, like I said, as you guys have brought up in the chat, there could be others. So we could expand this theoretically to address all of those. But let's see how then we would take each of these down its own leg. So if we broke our chain into these 4 failure modes and look at we ask why each of those happened. And we can say, why was the dome light all night? We already established that the door was left open. But what about corroded battery terminals? That could be due to a lack of maintenance. Maybe he's not routinely cleaning the battery cables or having them cleaned, and that's causing corrosion. Perhaps in the alternator system, the alternator may be failing with regards to his charging system, not outputting sufficient voltage to keep the battery charged. And then aged battery, it's a lack of keeping track of how old the battery is and replacing it on a timely basis. Most batteries have a limited lifespan, in the car battery, and they should be replaced every few years. So there's multiple paths here. Any one of these could, by themselves, contribute to the car battery being dead and result in our event. So we see this as an example of an or situation. All right. All right, so we're going to talk about Bob again. So again, Bob has lots of trouble getting to work on time. So this time he has a flat tire. And the story goes, one morning, Bob opened the garage to get into his car and leave for work, and he noticed the driver's side front tire was flat. So he jacked up the car, pulled the flat tire off, put a spare on, went to work. He was an hour late due to having to change the tire. Coming home that evening, he again parked his car in the garage. And the next morning, as Bob again prepared to go to work, he was greeted by another flat tire. Again, on the driver's side, front tire. Luckily, he was able to get a ride with a friend who also helped Bob pick up the original flat tire from the day before at the car repair shop where he had dropped it off. When Bob picked up the tire, the mechanic showed him a nail that he had run over that caused his flat in the original tire. So after Bob's friend dropped him off at home, he started the process all over again to swap the spare flat tire out for the original tire that had now been repaired. And he jacked the car up to pull the tire off, and he noticed that there was a nail in the flat again. So Bob looked on the floor and noticed that a sprinkling of nails, exactly like the one that the mechanic had showed him and the one he saw in the current flat he was taking off, were all over the floor. And so he starts to wonder, how did I get all these nails on the floor to begin with? So he looks around and he notices that a box containing the nails sit on a shelf above the workbench that's positioned in the back of the garage on the side which he parks his car. Okay, and so he continues investigation and he's looking at it, and he notices the box containing the nails that fell onto the garage floor had a tear and a water stain. So no source of water was anywhere near the box that he could see. So he's puzzled about how the box got wet. And as he looked around and up toward the roof of the garage, he also sees a water stain. Bob pulls out the ladder, goes outside, climbs up on the roof to see where this may be coming from, and looks on top of the garage and notices some of the shingles are missing. Okay, so he's thinking about it, and he suddenly remembers that the neighbor's tree was struck by lightning during a summer storm, and a major branch came down and struck the top of the roof of his garage, right in the spot where there was missing shingles. So now Bob starts to realize that when it rains, the rainwater must be leaking through the roof, dripping onto the box containing the nails, causing a tear in the box, allowing the nails to drop onto the floor. All right, so let's look at what this scenario would look like in a cause chain. All right. So Bob did not arrive at work on time. He had a flat tire. There was a nail in the tire. Why was there a nail in his tire? Because there were nails on the garage floor. Why were there nails on the garage floor? Because the box on the shelf split open. Okay. Now here's where we can have a breakout that could have multiple causes. And it's an and scenario in this case. Both of these have to happen in order for the next event to happen. So first, the box got wet. And we understand why the box got wet, because rain leaked through the hole in the roof. And Bob did not inspect and repair the roof after the storm, and the roof was damaged during the storm. So both the roof had to be damaged, and Bob had to have not taken care of that damage for the rain to leak through the roof. Right? If either of those had been mitigated, then he wouldn't have had the leak. But since he didn't do either, the rain leaked through the roof, the box got wet, and everything else above it happened. Now, not only, we also have another side of things to consider. The box was made of paper. Now, why was the box made of paper? Well, Bob had purchased the cheaper nails from the store that came in a paper box instead of a plastic box or bin. Now, had he had a nail stored in a plastic container, then the water would not have caused the container to break down and tear and make the nails fall on the floor. So here you can see there's several things that we can look at and several causes that had to be in place for the chain of events to actually happen. And you can see that they all had to be in place and had to for the events to happen.
All right. So hopefully that you guys like that example. We're gonna get on to another example that's I don't know, say really long. And honestly, you come across these examples all the time, and you got to make the most sense of them. All right. So as a plant manager is walking around the floor, he finds some oil on the floor. You know, whoa, what's going on here? This is a trip hazard here. You know, you can't have oil on the floor. He goes, grabs the foreman over and says, "Hey, I see some oil on the floor." And so the foreman goes, "Yeah, you're right. We've got this machine. It's got a leaky gasket." He goes, "Well, leaky gasket? Yeah, we keep replacing it. Keeps leaking. 4 over the last few weeks, and each one seemed to leak. Now, it's supposed to last a long time, these gaskets, but you know, seems like every so many days we got to keep replacing them. And we actually have a catch basin. And the catch basin is supposed to catch the oil, but that catch basin keeps overfilling. You know, and then the oil's getting on the floor because you know the safety protocol that and right, we have that dual system in place. It's not supposed to leak. Plus, in case it leaks, we have a system that catches it. It's not catching all the oil. All right, so foreman indicated that you know in general we've been getting bad gaskets. Like you know, it seems to have gotten worse over the last couple of weeks. But you know, when we went to go look at the catch basin, it was clogged with debris, probably from all that oil going in there. And so many times we've cleaned it out, it's now catching some other debris in there, and that's what's going on with that catch basin. So he's like, okay, well, what's going on here? He's like, you know, let me go to purchasing and find out what's the quality issue of these gaskets. So the plant manager now walks over to purchasing and going, hey, what's going on with these gaskets? They're saying that, you know, can't you get your supplier straight? There's gaskets coming in bad. And every time we come in, we get these leaks. And by the way, the leaks are overrunning in the catch basin and it could be a trip hazard. So the purchasing manager indicates that they've been trying for the past 2 months to supplier to make good. It's like, hey, we keep sending them back. They said they're sending a good one. There's 5,000 gaskets they send us, and they all seem to be bad. So the plant, and we bought them in bulk because we wanted to save some money. So the plant manager then asked the purchasing manager, well, why do they purchase, you know, so many from the supplier? And if they're so disreputable, you know, why are we buying them? And the purchasing manager goes, well, you know, the cheapest, lowest bidder. And we got quotes from a lot of different suppliers, but they happen to be the lowest bid. And then the plant manager, well, just because they're the lowest bidder, you know, why would you go with them if you know they're not necessarily the best company? Well, so you got to go talk to the VP of Finance on that one because you know we present the bids and we go through our council and we choose the lowest bidder. So plant manager now goes to the VP of Finance, says, hey, I'm just you know on the shop floor. There's oil on the ground, and because there's oil on the ground, people could slip on it and slip on it because the gaskets are faulty and we've been getting bad gaskets for a while. And when I asked the purchasing, they said they always take the lowest bidder because you guys say that you have to take the lowest bidder. And so the VP of Finance says, well, yeah, that's because the plant manager said, you know, we have to be more cost conscious as possible. So, you know, purchasing from the lowest bidder saves us a lot of money. In the end, the plant manager was horrified and he realized that he was almost the reason why there was oil on the plant floor. Well, bingo. So, you know, we bring this example in because this can happen sometimes. We could focus on the cultural part. We'll focus on what I will call the direct causes as well as not necessarily the indirect causes about the purchasing the lowest bidders and stuff like that. But let's go on to the example. All right. So we got oil on the floor. As we stated from the example, well, why did the oil get on the floor? Well, it was overflowing from the machine basin, right? And I could have put a step in there, you know, the bad gasket, but let's start with that. Why was it overflowing from the machine gasket? Because the machine was leaking oil more than the basin could handle. That's really the backing up the root cause. We start from oil on the floor, comes from the catch basin. Catch basin is overflowing. It's not supposed to overflow. Why is the catch basin overflowing? That's when you get to the and. So think about it. Typically, when we're supposed to do these, we always start from what the problem was and back up some steps, right? So So always they should be the event, the direct cause, a contributing cause, and back up. Because right away I could have said leaky gasket, but really it wasn't just a leaky gasket. I start with oil on the floor, over the basin overfilled. Now, there's where you have the and. I could have just said leaky gasket if I would have went straight to problem solving mode without looking at it from a root cause and a fault tree analysis. The only way that this really could happen is the bad gasket and the basin drain was plugged. In other words, this shouldn't happen. I actually put a fail-safe system in place, or so I thought, and that fail-safe, the basin, the catch basin was plugged, right? So, by the way, solving either one of those gets rid of the problem, right? Either we get good gaskets and we never have an oil, which is the preferred solution, or that clogged debris needs to be, removed and never there. So when we look at this, right, we may choose to continue to buy bad gaskets, right? So go one more progression, right? We could initiate an 8D with the supplier, or we could put TPM in place if we choose the gaskets. We may want to solve both. All I'm getting at is that when you're doing these and fault tree analysis, you actually have an option because both things need to happen, right? Going back to the how does a fire made? Well, I can't get rid of oxygen. I can't get rid of fuel. So I tell people, please don't create an ignition source. Same thing here. I could say, well, you know what, we'll deal with the gaskets. I'm not saying it's a good, and we could just do good DPM and we won't have the problem. Or we can just initiate the AD with the supplier and maybe the TPM doesn't need to be put in place, or solve both. That does turn into an or question when you go to solutions, because in an and situation, both have to happen. All right, so that's my example.
All right. So we'll move on to yet another case study here. Number 4, this is about the Jefferson Memorial. So again, if you were in our previous webinar, you may remember this example. This is about the Jefferson Memorial, which is built in a neoclassical style. You see the pictures up here in the upper right. It is in the West Potomac Park on the shore of the Potomac River in Washington, D.C. in the United States. So it's part of a series of memorials and monuments that are in this general area. We'll see a map here on the next slide about that. But the event that we're looking at here is a few years ago, the National Parks managers noticed that the Jefferson Memorial was crumbling at an alarming rate. And when they asked why, they found out that it was being washed far more often than the other memorials in the area. And for most organizations, the analysis would probably stop here, right? The solution is clear. Just adjust the cleaning schedule to match those of the other manuals. Quit cleaning this one so much. But unfortunately, that would have led to a very dirty Jefferson Memorial because they were washing it because it was dirty. So we needed to really dig deeper. We need to ask some more questions. And they did that when they asked about the reason for the frequent washings, why are we washing this one more than the others? They found that it had an exceptionally large amount of bird droppings on it every day. So what will be the solution now? Now we have bird droppings. So we're having to wash it because there's more bird droppings on it than anything else. So we probably need to find out why that's happening. Okay, so that's what they did. They kept digging. So they kept inquiring why there was more bird droppings that occurred at a higher rate on the Jefferson Memorial than they did on all the other memorials. And they discovered that the memorial harbored an incredibly large population of spiders. And spiders were a food source for birds. So these birds were coming in and feeding on these spiders. And the population of spiders had exploded because of the large number of midges. So midges are tiny aquatic insects that were in and around the memorial. So we see this food chain cause developing here. So when they started to continue digging deeper, the parks managers asked why there were so many midges that were congregated on the Jefferson Memorial. they found that the midges were stimulated to emerge and mate by a combination of a unique quality of light and moisture that was present here at the memorial. So it just so happened that the park managers were inadvertently creating this unique quality of brightness and turning the lights on the memorial just before dusk. This timing of the lights combined with memorial's location was actually leading to the event here through a series of causes that we're going to see in the next few slides. We'll see how this works out in the cause chain. So for reference, here's a map of the city, Washington, D.C., and you can see the various memorials here that are positioned in various places around the city. And so they're looking at the Jefferson Memorial, which is this one here in the lower right, and we see that it's positioned on a little, I'll say, a promontory kind of out in the water, sticks out into the water there. So it's much closer to the water than any of these other memorials. You can see that in the picture. And again, it was the problem we're trying to solve was they were washing this one because it was very dirty and it was crumbling. So let's look at our cause chain. So our event was the Jefferson Memorial was wearing away at a greater rate than the other monuments. So we asked why. Why was it wearing away? And we can see them having to do some restoration work on it there. So why was it wearing away at a greater rate? There's actually two reasons for this, and we'll see how this breaks down here at this point. One we've already talked about, it was washed more frequently. But also the material of the memorial contributed to the rapid decay. All right, so we asked why was it washed more frequently? Remember, our park managers already asked this question. And that was due to the large amount of bird droppings on the memorial. He said, well, why is, then we have a picture there of the bird droppings and the spiders that we talked about in a minute. Why were there so much bird droppings? Because there were lots of spiders and spider droppings. So we not only have bird droppings, but spider droppings, spider webs, lots of dirt being accumulated here. And why was this happening? Because there was the abundance of midges. So the midges, again, we talked about, are the food source for the spiders. So we see this chain of events emerging here. Midges feed the spiders, spiders feed the birds, birds leave the droppings. And then we come to an AND gate. So there are a couple of things that need to be in place for midges to be present. Here we see the end result. So for the midges to be stimulated to emerge and become a food source, there had to be lighting at the right time. So bringing those lights on right at dusk, as well as moisture. And there were actually two sources of moisture being introduced here. One was the memorial's proximity to water, which was the initial moisture source. But also, every time they're washing it and cleaning it, they're leaving residual moisture in and around the memorial, which also contributes to, again, that wet and light combination that's needed for the midges to survive. Now, on our other side here, we see that there was another contributing chain of events, was that the primary material for this memorial was marble, which is significantly softer than other monuments that were made out of granite. So the combination of having to wash it so much and it being a softer material was also a contributing factor to its wearing away at a greater rate. Right, so we see that, again, the water needed to be present with the light in order to stimulate the midges, which became this food source for the spiders and the birds, and then ultimately resulting in the wearing away of the monument. And here we see there was so much moisture, they actually had plants growing out of certain portions of the monument. All right, so hopefully these examples were helpful for you. Now we have a Q&A session. So Marnie, I'll let you take over for here.
All right. So does anyone have any questions? So we got a couple comments of feedback. One of them was, "This is very cool. I thought if you had to introduce an end, you weren't asking the right question."
Well, I'm glad that we helped you on that. No, an and can be the answer. um, and it's amazing sometimes because everyone thinks it's one thing, but two things many times have to happen to get the result. Right? I mean, it happens all the time, even by nature of talking about, we have a direct root cause and detect root cause, right? Same kind of idea. We have an escape because both of them failed. So that failed and that failed. So it's common and very good to remember sometimes because you may fix one thing and maybe need to fix both.
All right, and we have another comment, and I'm not. I think it's Bob and the tire, but it might be top the factory one. That we should have included 5S. The lack of 5S.
Yeah, that was a good catch. Yeah.
Yeah.
Yeah, I think there's the one question or at least comment about, yeah, we could have went down the path of the purchasing and that. Honestly, those were very cultural issues. You could include that in your analysis of ands and keep going down further, but I tend to look at the product and the equipment as opposed to the people. Because if you fixed either one of those, it wouldn't even matter if they bought the worst gaskets ever. It looks like they were important. And I'm not saying you can't do that. I'm just saying that stick to the product and the machines sometimes. But we have some
All right.
interesting comments about pH, maybe.
Yeah. So we have a
So
question.
we didn't have that yet.
So how do you manage a very complex and large analysis?
Yeah. What I would say is that you have multiple branches. I can't say I'm world class at fault trees, but having experienced seeing some very complicated fault trees, you have multiple legs and you go down each leg. Um, so that's what I've seen. If you think about a complex system, you can you can start at the system level. The subsystem level can each have their own fault tree. And if you really want to look at some really good benchmarking on complex systems, it's reliability analysis uses them all the time because when they're determining the reliability of a system, you look at the faults and the ands versus the ors for that system. And really, if you think about it from a PFMEA, you get the failure modes, right, of your parts, or if you're looking at a DFMEA of the design, but those can help you understand, those different legs of what could cause that. And those are your ands and ors. So, so it's very common to have complex systems. The engineering and reliability analysis uses them all the time.
All right, next question. So does that mean there can be multiple root causes?
Well, in an and, both have to happen. So I don't know if it's multiple root causes. It's both of them together make a cause, because without the other one doesn't matter. Um, so I guess it's a little bit of semantics. You could say it's multiple, or you could say it's one root cause with an and. And
What are the best? Oh, go ahead. Sorry,
oh,
Peter.
the other way of looking at that, and why it's great to have that in a fault tree analysis, because you can show those are connected.
All right, so your next question, what are the best ways to link the findings on the PFMEA and the control plan?
Yeah, so again, I think I mentioned it a little bit. If you have all of these causes that could create the failure mode or the event, because the event is the failure mode, you would have them on your PFMEA. And then really your control plan, there is a lot of, I would say, different ways of creating the control plan. But if you work on an RPN scale and look at the high RPNs, then the causes, right, that have the highest probability, right, because that's what the RPN score gives you, those would be the ones you take over to the control plan. So one thing you could do is you could either, start with a fault tree analysis and put them into your PFMEA, or if you really wanted to, you have done a really robust PFMEA, you could put them on a fault tree to show it visually, and you could include ANDs then. I do like Pete's comment, so I will talk about that. He does say that there are multiple root causes to any problem. As I talked about, like I said, we always talk about, detect and direct. So, always think about that. It's okay to say there's multiple root causes.
All right.
Yep.
There was another comment from Pete too that was good, which is for an end gate, it means the lower level causes beneath that end all have to happen in the same space and time for that top level to occur. And then good reminder, thanks Pete. If you want to see really good connections between PFEMAs and the 8D, there was a webinar on that just last week. So the link is there on the events page under past events. Any other questions? Adam, do you want to advance it? And if one pops up, I'll just stop and we'll do the next question. All right, so we just wanted to mention our planned events for 2024. So the one that Pete mentioned, the 8D interactions with PFMEA, that was completed last week and is now available on the AESQ website under events than past events. We just completed this one, developing multiple path root cause analysis. We have 2 more planned from this subject interest group this year. How to describe a nonconformance, and that'll be a new section in our RM to help describe nonconformances better. And the last one will build off the case study we currently have in the RM of when to use 2D, 4D, or 8D. So depending on the complexity of your problem, how you can use the 8D methodology and shrink it if needed to fit the size and scope of the problem. So please remember anytime that you can provide us feedback on RM 13,000, there is a link on AESQ that goes into the office and then it sends out to us so that we have feedback on what you want more information on, where you need help, chapter development, stuff like that. The QR code will take you to the AESQ events. So beyond the main page, it takes you right to the events tab so you can see all the events, not just the ones from our SMIG, but from all of the SMIGs, past and present, with that QR code. And the next one I'd say is, what other webinar topics would you like us to provide on problem solving? Please feel free to add a bunch in the chat window. We're always looking for, what is it we can provide the supply base? And then, how could we improve our webinars? What is it we could do better to make them more informed and more useful to you? I think the last 3 have all been very different in format. All right, just to summarize, so if you think of something later on today, you can send it to the info@AESQ, link on the AESQ website. So this webinar has been videoed. It will be uploaded in a couple days to the AESQ website. In addition to that, an email will be sent to all the people who have registered for this webinar directly. You'll get that link directly to the video so you can watch it again pass it on to a friend. We're always open to question and answers. If we, when you send them in, we reply. We do actually reply to them. If it's an update that's needed to the RM, it may take a little while to do it. But we will get back to you as to what our proposed changes would be. And then the presentations as well are uploaded on the AESQ website. So thank you for that. I appreciate that clear examples. You like the clear examples that we had. And thank you everyone for attending. The nonconformance webinar is not yet on the website because we haven't picked a date for it. It is expected in the fall. So the last two I posted up there, we don't have specific dates yet, but do watch for those. We do post them in the LinkedIn website, post them on AESQ, and try to email them out as well as best we can. Great. I'm glad people are excited about the nonconformance webinar. All right. Thank you, everyone. Have a wonderful day, afternoon, or evening.